Hi guys, so for today's lesson we're going to be dealing with negative indices. Okay, so what do I mean by a negative indice? Well, when a base is powered to a negative number, that's when you get a negative indice. So it's pretty much just like your power is just some sort of negative number. So just firstly, before we get into the rules, I just want to show you a bit of a pattern with these negative powers. So let's have a close look. So on top you've got all the powers, and then you've got their value underneath. So like 5 to the power of 3 is 125, 5 squared is 25, 5 to the power of 1 is 5, and obviously anything to the power of 0 is equal to 1. So you'll notice that the powers are going down by 1 at a time, and we want to try and see if there's some sort of pattern we can use to help us out with these negative numbers. Okay, so if you look at the values each time, you'll notice that they're being divided by 5 each time. So if we continue that pattern for these negative powers, maybe that'll help us kind of understand how these negative powers work. So we're dividing by 5 each time, we eventually get to 1, and then we continue the pattern. 1 divided by 5 is 1/5, and then 1/5 divided by 5 is 1/25, etc. You'll notice that these numbers of 5, 25, and 125 repeat, but they're on the denominator for these negative powers. So that's kind of the idea here. This is a bit of an insight into how these negative powers work. So pretty much this is the same as 5 to the power of 3, but that's just on the denominator instead of just being a normal number. And that can be pretty much it. Okay, so let's do some rules to remember pretty much explaining this. So when a base is powered by a negative number, it is usually preferable to simplify the expression to have positive powers only. So we want to change these negative powers to a positive power. So pretty much we want to be changing this to this because we're getting rid of all those negative powers. Okay, so first thing, this is a bit of the first strategy that you want to apply. So you want to remove the negative symbol in the power by converting the base to the reciprocal version. So it's pretty much changing it to the flipped version. Reciprocal means the flipped version. So you flip the fraction. And then you apply the positive power to that reciprocal. So let's do some examples. So first one is x to the power of negative 5. So the idea is we want to change our base, our x, to its reciprocal. We want to flip x. Remember that x is the same as x over 1. And if we flip that, it becomes 1 over x. And we still want to apply the power of 5 to it, but notice how when we flipped it, the 5 has turned it to its positive version. So we need to apply that power of 5 to both top and bottom when we're dealing with this fraction. And 1 to the power of 5, well, anything to the power of, or 1 to the power of anything, it stays 1, because like 1 times itself 5 times stays 1. And then x to the power of 5, that's just going to be x to the power of 5. So you can see here with this x to the power of negative 5, the base of x and the power of 5 literally just went straight to the denominator, and 1 was left over up the top. E.g. 2, let's try this one. So 3 over 2 to the power of negative 2. Well, the idea is you want to flip the fraction, so just flip it, take the reciprocal, and change your negative power to its positive version. And then when we apply the square to both top and bottom, you get 4 over 9. Let's do another one. So e.g. 3, so 5a x to the power of negative 1. I want you to notice that the minus 1 is only applying to this x. So therefore, we take the reciprocal of only the x. So x goes to 1 over x. The negative 1 becomes positive 1. And look at the 5a. The 5a literally hasn't changed. That just literally moved over. And the reason is because there's no negative power to deal with. So when we apply the power of 1 to this, well, power of 1 is pretty much just the same thing. You can just get rid of the power of 1. So we're left over with 5a multiplied by 1 over x. And the 5a can literally just multiply by the top. And the reason for this is, remember that 5a can be over 1, and then top times top, and bottom times bottom. And we get 5a over x. So another way to look at this one is that the x was powered to the negative power. That x moved down to the denominator to the power of 1. Let's try another one. So this is 5ax, which is all powered to the negative 1. That means we need to take the reciprocal of all of this, meaning that goes from 5ax over 1 to 1 over 5ax, and that power of negative 1 turns to its positive version, and anything to the power of 1 does not change. That's our final answer. So notice that this negative power literally moved this all down to the negative to the denominator. Okay, so when dealing with large fractions and several bases, I forgot that, and several bases, comma, it can be helpful to deal with negative powers using the it can be helpful to deal with helpful powers using this alternate strategy. So it's a bit of a second strategy to help you with this. Okay, so the second strategy involves negative powers move their base from numerator to denominator, or vice versa. So it's all about these negative powers moving the base from top to bottom, or bottom to top. The positive version of the power moves with the base. So pretty much you want to move these bases from top to bottom, or bottom to top, and the positive version of the power stays with that base which is moving. So let's give it a try. So EG5, have a look at this one. You've got a couple of negative powers here. How do we make these powers become, or move into their positive version? So the idea is that this negative power of x, because that's on top, that negative power is going to move it to the bottom. So the x to the power of minus 3 changes to its positive version down the bottom. It went from top to bottom. And this 5 to the power of negative 2, that moves from bottom to top, and the negative power changes to its positive version. Because it's all about getting rid of these negative powers and converting them to their positive version. 5 squared makes 25, and the x to the power of 3 stays down the bottom. Okay, let's try another one. So this one's a bit trickier. You've got a negative power here, negative 2, and you've got a negative power down here. They're literally going to swap from top to bottom, or bottom to top. Everything else is powered to a positive number, like this and this. They're positive powers, and also this, it doesn't have a power. They are going to stay put because they're not negative powered. So the a to the power of minus 2 becomes its positive version down the bottom, and the x to the power of minus 1 becomes its positive version up the top. And this can simplify. This can simplify your x's when they're next to each other, they're multiplying, your powers will add. So 1 plus 4 makes a power of 5, and your y's and your a's stay down the bottom. Okay, so harder examples. So simplify the following expressions using positive indices. Okay, so let's have a look at this big expression that we need to try and simplify by getting rid of these negative powers somehow. Okay, so the idea is that when you are powering other powers, so this is an example of a power of powers, you want to be thinking that your powers are going to be multiplying. So first up, your negative 1 power has to apply to all 3 bases that are inside your bracket. So the 4 gets powered to a negative 1. Now the negative 3 power inside gets powered to a negative 1. You have to think to yourself, negative 1 multiplied by negative 3, that's going to give you positive 3. There's 2 negatives multiplied to give a positive. Negative 1 times 2 gives you a power of negative 2. So you're left over with an expression like this. Now remember, anything that's powered to a negative number now that we've got rid of our brackets, they are going to move from the top down to the bottom. You're going to, they go from the numerator, which they're all over 1 at the moment, they're all on top. They're all going to be the bases with the negative power are going to be pushed down to the denominator. So 4 to the power of negative 1 becomes 4 to the power of 1 down the bottom. And y to the power of negative 2 becomes y squared, positive 2, down the bottom. And 4 to the power of 1 is just going to be 4 down the bottom. So that's our final answer right here. Question B, a little bit tricky again. We've got all these brackets to deal with. So again, we've got powers of powers. So we're going to be multiplying these numbers together. So x to the power of 4 times 3 gives us our x to the power of 12. 3 times negative 2 gives us y to the power of negative 6. And this one here, the negative 4, is going to go with the x to make x to the power of negative 4. It didn't have any power with it. And lastly, the minus 4 is multiplying with the power of 2 to give y to the power of negative 8. When you get to this stage, we've got rid of the brackets, we need to deal with this multiplication sign. When you're multiplying, you want to add the powers which have the same base of x and y. So here we've got our power of 12 adds to our power of negative 4 because they've both got x as a base. So 12 plus negative 4 is a power of 8. And with our y's, we've got y to the power of negative 6 plus y to the power of negative 8. So negative 6 plus negative 8 is going to be negative 14. And finally, we have to deal with this negative power. Because the y is up the top on the numerator, it's going to be pushed down to the denominator. And the negative 14 is going to turn to its positive version. So finally, you get this as your answer. I hope this helps with the questions. Good luck.